Okay, great. Hello, everybody. So, 10 years ago, I was a student doing computer science at a university in Serbia. And back then, I applied for a competition which was not related to the studies. It was a case study competition, and I was competing against other students, and we needed to come up with a solution for a case that we were presented. And the main sponsor of this event was a major computer retailer in Serbia. And back then, they needed a web app for end users where customers would be able to build their custom desktop configurations. And, of course, pick all the components that they want, and then pay for that and have that delivered. That's something which is pretty normal nowadays, but 10 years ago, 2007, it wasn't. We were not asked to do any coding. We just needed to come up with a concept with like how the whole web app would look like, how it's going to work. And we were presenting our solution in front of a jury of 3 people. And I was doing my presentation, and I was saying something like this. I was saying like, you're going to have a drop-down on this page where you will be selecting your components. And the first drop-down is going to have a list of CPUs that you would be able to choose from. So it's going to be AMD or Intel or something else. And once you do that, the next drop-down is going to be enabled, or it's going to just show up. And then based on your first choice, you will be able to choose the motherboard accordingly. Because, of course, not any motherboard can go with any CPU. And then after you make that choice, you will be able, again, to have a third drop-down, and you will be able to select your RAM modules, and so on. And I finished my presentation, and one of the jurors, who was assistant professor from university, he asked me, how are you going to pull off the drop-down thing, like drop-downs being dynamically generated and fed with data? And I said, well, I'm going to use JavaScript for that. And he said, why JavaScript? And I was a little bit confused, and I said, well, why not? And the other juror, she commented, how dare he ask us questions? We're the ones who are supposed to be asking questions. And she was insulted a little bit. But this assistant professor, he was OK, and he said, he decided to reply, and he said, well, you know, it's bad practice to use JavaScript. JavaScript should be used only when you really have to, when you have no other solution, and you really have to use it, but otherwise it should be avoided. Guess who won? I didn't. Somebody else won, who was smart and chose not to use JavaScript. If you fast forward 10 years, and now 2017, you see that things have significantly changed, and that JavaScript is everywhere. And it has moved also to backend, and we have it on servers, and we have it in desktop applications. You can build your Electron apps, and so on. So it has expanded a lot. But back then, this assistant professor, he wasn't wrong. That's what we were really taught at universities. You know, it's a bad thing only if you really, really have to. My name is Miloš Bošković, and today I will be talking about next potentially interesting step for JavaScript, and that's TypeScript. Whether you should move up to TypeScript, and if you decide so, what the migration path would be. So first, I'm going to talk a little bit about TypeScript, what it is, and give some examples. And then we're going to talk a little bit about migration path. TypeScript, of course, offers a lot of features, and there's just not enough time to cover all of them, of course, so I'm just going to go through some major ones. By the way, I'm a front-end developer, and I work from a city called Niš in Serbia. Interesting side note, if you decide to go to France, pay attention when you're buying tickets, because some guys decided to go to Nice, to France, and they ended up in Niš in Serbia. So just have that in mind. That really happened. So right now I'm doing Angular 2 with TypeScript, and I started doing development in 2011. Initially I was a full-stack developer, junior full-stack developer, which is, you know, as much as you can be full-stack when you're a junior. And then slowly, as I was moving from project to project, I started working more on front-end projects, and for the last like 3 or 4 years, I have been using Angular 1, and now recently I started using Angular 2. So a little bit about TypeScript. It was made in Microsoft in 2012, and it was made by the guys who were also who also worked on C#. And my impression is that, and maybe I'm wrong, is that it really picked up the pace with Angular 2, because Angular 2 arrived like half a year ago, 9 months ago, and they were the ones who were strongly pushing TypeScript. And this was interesting because Angular is a Google project and TypeScript is a Microsoft project, but still they really work together. One of the main ideas of TypeScript is to always stay one step ahead of the current ECMAScript version that we have. So whenever the guys who are working on the future standards for ECMAScript decide that something is going to be implemented in a couple of years, the guys from Microsoft, they're going to take that and put that right away into the TypeScript so that you have that available right now. So that's one of the main things related to TypeScript. And another one is, of course, types, as the name suggests. So JavaScript, as we all know, is not strong typed language, but TypeScript is trying to introduce that with its syntax. TypeScript is a superset of JS, if we're going to be using mathematical terms. And that means that if you write something in ES6 or ES5, TypeScript is going to accept that and it won't complain. And that's one good thing about migration. So in theory, you should be able to take your existing JavaScript project and just add TypeScript compiler, and everything should be working just fine, more or less. So it compiles to ES6, ES5, ES3, or the latest one, ES 2017, whatever you choose. And of course, it works well with source maps. Do we know what source maps are? Or should I explain? Yes, no? Okay, so usually when you try to compile something from your like CoffeeScript or TypeScript or something, you're compiling it to JavaScript, and then when you run that in the browser is running that JavaScript. It's not running TypeScript, it's not running CoffeeScript. And then if you want to do some debugging, right, you're going to end up with a compiled code that you will be looking at in your browser. And source maps enable you to see your original code in the browser. So if I'm writing my TypeScript code and it's compiled to JavaScript and I run that in the browser and I do some debugging, I will be seeing my TypeScript files. So that's the important thing. And also, as I stated right now, your TypeScript is not reaching the browser. It's always being compiled into JavaScript. And of course, file extensions are TS rather than JS. And if you think about it, about what TypeScript offers, it offers strong typing and so on, but everything, all of that is stripped down, and you're not getting that in the end in the browser. TypeScript can be considered sort of a documentation for JavaScript, because you're using types to explain what your functions, for example, function or classes, are doing. So it's definitely very useful, and we'll get to that a little bit later. Okay, demo. Let's give that a try. So many things can go wrong. Hopefully nothing will. I'm going to delete this. Should I? Okay, I'm going to start typing, and you can tell me if I need to zoom in. Okay, so let's try. Let me just explain. So this is a TypeScript lang site. That's what it's called. And of course, on the left-hand side, I will be typing my TypeScript code, and on the right-hand side, right away, you will have your JavaScript code generated automatically from TypeScript. But first, let's try to write some ES5 code and see what's going to happen. So I'm going to write a class like this, function conference, and it's going to accept 2 parameters, name it, and a list of attendees like this. And you can do something like this name equals name, and this dot attendees equals attendees. Okay, and maybe I can write a getter function here, prototype, like. Do I need to zoom in? Okay, great. Oh. Equals function. and not blur, no, no. And it's gonna, of course, return this dot and then this. Cool. Okay. So on the left-hand side, I have TypeScript, so to speak, and then when that's compiled on the right-hand side, one new line is lost. Everything else is the same. So as you can see, if you try to pass regular ES5 to TypeScript compiler, you're just going to get ES5. Nothing's going to change. Which means that your project in ES5 should work just fine when you add TypeScript compiler. Okay, let's try ES6 syntax for a change. And now I'm going to do class conference, and I'm going to have a constructor, and I'm going to have parameters, name, and attendees, like so. And now I'm going to introduce some TypeScript syntax. So JavaScript has no concept of private, public, or protected, right? But TypeScript does. So I can do here private, and I can do here private. And now once I did this, right away on the right-hand side, I'm getting these setter lines automatically generated for me. So I don't need to care about that. So TypeScript is going to do that for me right away, which is great. It just saves you from writing boilerplate code. I'm going to do, again, the same function, and I'm going to return, of course, attendees. And now let's try to instantiate this class, like so, conference, oops. Okay, and name is going to be FullStack, and for the time being, let's just put like John Smith or whatever. And now, what's going to happen if I try to access attendees, but not using the getter function, but like directly, like this? Oh, sorry, attendees. So I'm getting an error, of course, and TypeScript says that attendees, of course, is a private member, and it's not to be used outside of the class, which makes perfect sense. So that's what TypeScript enables. It's doing type checking upon compile time. However, if you take a look at the right-hand side, it's compiled normally, and even though I did get an error, I still get a proper JavaScript, and I can still run it, even though I'm getting this error. So that's one more thing which should help you when you're migrating. Like, it's gonna be coming up with errors, but still, it's gonna work. Like, just in case. Okay, let's add some more things. So now I can also define types for these two parameters. So name is gonna be a string, and attendees, let's make it a little bit complicated, like this. So it's going to be an array, like this. But you cannot, in TypeScript, you cannot just define an array. You need to define an array of something. So it can be an array of, for example, strings, like this. And of course, I'm going to get an error right away here, because this is not an array of strings. But let's make it a little bit different. This is going to be an array of objects, and each object is going to have a name, which is going to be a string, and it's going to have a read-only ID, which is going to be a number. So you even have this read-only keyword, where you, of course, suggest that this parameter is only to be read. Okay, and of course, now I'm getting an error here, because when I'm creating this object, let's just hover over, it says that argument is string, and it's supposed to be an array of objects. And that's something also that TypeScript offers in your IDEs or in your text editors. So now you will have these tooltips and IntelliSense telling you if there's something wrong and suggesting what you need to do. And for examples this small, it's really not a big deal. You know, it's going to be obvious that something is wrong. But when you have a really big project and you have a lot of people working on that project, this is going to be very, very helpful, because otherwise, without this, you will just
miss the error, you're going to run it in the browser, and somewhere, finally, you're going to run into it. But with TypeScript, you're able to track it down right away. OK, so here I can do now an array, and this is going to be an object, and this is going to be a name, and ID is going to be 5, and this is going to work now. OK, if you hover over getAttendees function, it's going to tell you that this function returns an array of objects. So it knows right away, since it's returning attendees, it knows right away which type is going to be returning. But since this object here is just pretty, it looks messy when you put it in constructor declaration, we can do it differently, and we can, of course, define interfaces. And again, interfaces is something that we don't have in JavaScript. So I can do an interface, and I'm going to say this is going to be attendee interface, and it's going to have a name, which is going to be a string, and it's going to have read-only ID, which is going to be optional. Even that, you can do even that. So now I can change this just to make it prettier. Oops. Attendee, like this. Something I did wrong. Oh, yeah. It's double T, right? Like this? OK. Oh, somewhere I was writing single T, somewhere I was writing. Did I spell it wrong? Is it with double T or single T? Double T. You should have told me that earlier. OK, never mind. I'm just going to leave it like this. So somewhere it's double T, somewhere it's single T. OK. And here I can define that, of course, this, even though it's TypeScript already knows, this function is going to be returning single T attendee, an array of single T attendees. Actually, double T. OK. Great. OK. Another thing that I can do here is, what if I wanted to do some bad practice for getAttendee function, getAttendees, and if there are no, just a sec, so like this, if this dot attendees single T, length, so if there are no attendees, I'm going to return a string saying there are no people, something like that. And otherwise, I'm just going to return this. And of course, again, I'm getting an error, and it says string does not match the type that you can define here is going to be returned. So that's not going to work. Of course, this is a bad practice to have a function which is returning either one type or another type, but just for the sake of presentation. So what I also can do here is, actually here, I can say that this function can return a list of attendees, or it can return a single string, like this. And now the error is gone. Although, again, it's not a good practice. And even you can use so-called type aliases. How do I call this? No. Something like this. So, and I can say that this is going to be returning, I'm going to define a new type like this. And then, of course, I can use this type and just pass it here. Oops. Control C for copy. Control V for paste. OK, great. So that's working as well. So if you take a look on the right-hand side now, you will see that interface is gone because JavaScript has no idea what interfaces are. And then you may ask yourself, why am I writing this code if it's not ending up in JavaScript? Why would I do an interface and type and so on? And in the end, it's just going to be lost, and JavaScript would have no idea of what that was. Well, the main idea behind TypeScript is to enable you to find your errors before you go to browser and hit F5 or reload or whatever. And that's what main idea of TypeScript is, so that you can track errors more easily, and of course that you can understand your code better, so that you know that you have specific types which are being passed to functions, or that function is returning some sort of type, and then you can better understand. Of course, again, for this, for a project, just like one file, it's so obvious, but when you have a big project, it can be very, very helpful. Okay, let's go back to the presentation. Other interesting features that TypeScript has, and this is the one that I just talked about, type alias. So this is where you are able to define a type and combine multiple types, and then you can, this variable which you assign this type to will be able to accept multiple types. And this is useful for some, well, for example, for function overloading, where you have a single function which can accept like a parameter with different types, and then in this way you can define that it can accept either this, for example, interface, or that interface. In this case, it's just string and number, but it can get much more useful when you're talking about interfaces or class objects which are being accepted. And this one feature is for me very interesting because it's just, well, I found it weird. And this is so-called never type. Never type. So type which is called never. And it's used for exhaustive checks. And now when I say this, it doesn't mean much. So let's see how it works. So one more example, which I'm not going to be typing, I'm just going to show you right away. Okay, so let's just explain this a little bit. Okay, so in the upper left corner here, you have a type, shape type, and it's defined as potential, like 3 different potential formats, and each one of them has parameter kind, which is already defined as a string and has a value, kind circle, kind rectangle, kind square. And these other parameters are different for different types. So one is radius, of course, width, height, size, and so on. And here you have this assert never function, which is never supposed to be run. And again, it's weird, like why do you write code which is not supposed to be run? And then this function is accepting an object, and this object is type never. Okay, that's weird. And here you have a function, getArea. Of course, it's going to calculate the area of the shape, and then inside it's accepting object of type shape. And inside you have this switch statement, which is going to decide on which shape, which kind of shape it is, and based on that, it's going to calculate the area. So now when you think about this piece of code here, you will see that there is no way that line 19 is going to ever be executed, because you have 3 different shapes. They are all covered here. Everything is working just fine. This code is sort of redundant. And in a way it is, but still, if you have a big team and you have a big project, maybe this first line here is going to be in one file, and this getArea function is going to be in another file. And then at some point, somebody is going to be asked to add one more shape. Let's give it a try. Like, oh, triangle. And it's going to have, I think, a base, which is number, and height, which is also number. Oh, and now I have an error. And the error is saying that this object here is supposed to be never, of type never, but there is a possibility that it's going to be shape of type triangle. So what I initially did with this assert never code is I just added sort of a future-proof piece of code just to make sure, just to be able to warn any other developer who would decide to add one more shape or whatever, to know that this function here also needs to be taken care of. So if here for some reason I decide to reference shape, TypeScript is going to know right away that this shape is of kind triangle, because all other have been covered in this switch statement. So the point of this code actually, and the never type, is just to do some sort of future proofing and to make sure that something never happens, and in this case actually just to prompt an error for some maybe critical code, which is very important, and you just need to pay attention. So this is a perfect example for that, even though it's still sort of weird. Okay. So let's talk a little bit about migration path. So what do you need to do if you have your existing JavaScript project and you just want to give TypeScript a try? What do you need to do? Well, you need to create this tsconfig.json file, and I'm not going to go into the contents of it. You can just Google it out. It's nothing special. You need to rename your JS files to TS files. You need to use your npm and to install the dependencies required for compiling your TypeScript code to JS code. And once TS compiler, TypeScript compiler gets going, there will be some errors. But these errors will be just like the ones I talked earlier. So you will have errors, but you still will be able to run your code. Good thing about TS, because it's a superset of JS, is that everything is optional, and types are also optional. So you introduce TypeScript because you want to have types in your project, but that doesn't mean that you need to have them right away. And one more useful type used for these sorts of situations where maybe you don't want to deal with types is any type, which you can use. So let's see how that works. So in regular JavaScript code, you will be able to have one variable as a number, another variable as a string, and you will be able to assign this first variable or second to the first one. However, in TypeScript, you will get an error, and it's going to say that you cannot assign a string to a number or a number to a string. And in that case, this any type can be very useful. So what you can do here is do bar equals foo as any. And in that case, it's going to work. So the point of this is that you can use these quick fixes in the beginning where you're just, when you just started migrating to TypeScript to fix all the errors that will be popping up, some of the errors that will be popping up. Similarly, you can have a function which is returning a number, and you have a variable which used to be a string, but now you want to assign a number to it. Again, TypeScript is going to complain, but you can easily tell it to bugger off by defining a return type of any. And even with my Angular 2 project that I'm working on, and I started that project basically with TypeScript, I didn't need to do any sort of migration. From time to time, TypeScript starts bugging me just way too much with types, and it's complaining about like not being able to infer which type this is or what type is being returned. And then just for me so that I can take a break, I just say, okay, it's returning any. So give it a break. So just forget about it. And at some point, I finally fix it. So the next question that comes into mind is, what about external libraries? So you have your code maybe fixed and it's working, but then you realize that you have a jQuery call where you're referencing some element in your DOM, and then you do, I don't know, append, and then you do .css or show or hide, and then TypeScript is going to say, I have no idea what these functions are returning and what parameters they're accepting and what their types are. And that's sort of a problem. And then when you think about it further, the next logical step would be to jump into jQuery library and to define all these types. But luckily, there is a solution for that, and that's a site called DefinitelyTyped. And this site contains declaration files for all major libraries that you run into when you're doing your development, jQuery included. So these files are .d.ts files, and what they contain is just declarations of all of the functions that library has. And you can just pull these files in, and then after that, jQuery is going to work just fine. And on top of that all, one interesting thing as well is that now that you have these declarations, you can, for example, do element.show, or I don't know, append or hide, and do control-click on them, and you're going to be led right into the declaration file so that you can see exactly what parameters these functions are accepting. So you can see their definitions. Of course, at some point, maybe you're going to have some library of yours that you don't have time to take care of and to introduce types. And in that case, there is also a quick fix. And here, it's presented for the case of jQuery, but you can use it as well. So you can just declare that library and just, again, say any. And it's taken care of. OK. So to conclude, TypeScript is definitely worth a try because it's easy to get it running. So it doesn't require too much time to get it working. And you're getting much cleaner code, which is just easier to read. And especially when you have bigger teams, it's easier to reason about that code, even though you're not getting this code actually in the browser. You're still getting JavaScript. But it's just going to be much easier for you to track down all the errors that you have. And you will be just able to write better code. And of course, I forgot about suggestions that you will be getting in the tooltips, where you will be able, if you define like functions that have parameters with specific types, and then you call that function elsewhere, right away you're going to get a tooltip, and then you will be able to see which parameters, which types these parameters are, and what you can pass and what you cannot pass, and so on. Some useful links for this. The first one is a book, TypeScript Deep Dive, and some of the examples I borrowed from this book because it's very, very useful. The second site is TypeScriptLang.org, and that's the one actually that I use for the demonstrations. And the third link is the one where the organizer asked me to put it in because that's where all these presentations are going to be shown. And in the end, this is the link to this presentation exactly, which is already available online. So thank you, and let me know if you have any questions.
Any questions? Yes.
Hello.
Hi.
So I noticed you're using lowercase types on your.
Sorry?
I noticed that you're using lowercase types, like your string type was lowercase rather than the JavaScript uppercase. What are the difference between the TypeScript types compared to the normal JavaScript ones?
Oh, like string.
Yeah.
There are no differences. So the string from TypeScript is exactly the same string from JavaScript, except that TypeScript is going to be bugging you about not being able to assign a string to a number or something like that. So with this primitive types, it's the same.
Do you worry at all about how much TypeScript has kind of diverged from ECMAScript in terms of runtime effects, like, I don't know, private class variables and decorators and so on?
Sorry, I didn't...
So are you worried about how much TypeScript has kind of diverged from ECMAScript? Like, how much do you feel like we're kind of sandboxing ourselves into a new language rather than just deploying type checking at compile time?
Well, I think that I think that what they're doing with ECMAScript and that they're following the roadmap that they have, I think that it's a good thing, and generally my opinion is that it's just a good thing to be always one step ahead in terms of the ECMAScript and to have that already at your disposal. I'm not sure if I answered your question. Maybe later we can go into details. Everything's clear.
Any more questions? All right.
Oh, there's one, I think.
Do you have named parameters for the functions? Can you call a function passing named arguments, or just a list of arguments as normally you do in JavaScript?
You can do it normally as it's done on JavaScript.
You can't use named parameters.
Named parameters.
Like when I call the function, I use the name. So I can shuffle them around.
Yeah, I think I know what you're talking about. Honestly, I'm not sure. I haven't used it in my projects.
Okay. Cheers.
So I'm using a subset of TypeScript in my project. So I'm just using some of the features that I like, and I didn't have a chance yet to use all of them. So that's why the only thing I can tell you, I'm not sure. Because there are so many things that TypeScript offers, and some of them are just not applicable in my particular case, and some of them I didn't use. So it's possible that it's there. By the way, that's one of the good things for TypeScript. So you can choose what you need for your project. So some things you don't need to use. Some, if you don't like them, others you can use. Okay? No more questions. Great. Thank you.